Welcome students. In this class we are going to solve a regression relation an equals 8an minus 1 plus 10 to the power n minus 1 by using generating function. In the previous case we solved the problem which is of linear homogeneous in nature, but this problem is, what type of problems can you tell me? This type of problem is what is called linear non-homogeneous recurrence relations. Linear non-homogeneous recurrence relation, that's what is this one. See the format, and this we call it as associated linear homogeneous function, and this is what we call f of n. So let us solve. The given recurrence relation is an equals 8 n minus 1 plus 10 to the power n minus 1. Multiply both sides by x power n. You'll get 8 n minus 1 x power n plus 10 n minus 1 x power n. How this comes? Multiplying both sides by x power n. You will get equation number 1. Right. Now we know the general form of a generating function g of x equals summation of n tends to 0 to infinity a n x power n, where a0, a1, a2 are the sequence for which the generating function is this. Now n is equal to 0 is substitute. What will get? a0 x power 0, a0 x power 0, and then the remaining summation is, see, n tends to 0, so delete that. Then from n is equal to 1 to infinity summation a n x power n. You must understand that here the value of a0 is 1, although it is not given in the problem. It is given as 1, implies a0 x power 0, x power 0 is 1, so a0, so instead of a0 they are putting 1, implies a0 must be equal to 1. It must be given in the problem, but it is not given, no problem at all. We substitute that here. So this summation split up into 2. For n is equal to 0, the first term, and for n is equal to 1 to infinity, we get an x power n. Now g of x is this. Now g of x, I am subtracting 1 both sides. What I will get? G of x minus 1. That side, this 1 will go out. This you will get. Summation n tends to 1 to infinity a n x power n from equation number 1. Now look at that. Subtracting 1 both sides. This 1, that minus 1 will get cancels. You will get gx minus 1 equals summation n tends to 1 to infinity a n x power n. But what is this an? From equation number 1, go back, you see there an equals an minus 8 into an minus 1 plus 10 to the power n minus 1. An equals 8 an minus 1 plus 10 to the power n minus 1. So that an, in the place of an, we are substituting this, okay. Then x power n will come there, x power n. So this bracket will not come here, it has to be finished here. Xn should go out. There's a small mistake there. This xn will come out and it will not be inside that, because xn is common for this an only. We are substituting this value 8 an minus 1 plus 10 to the power 10 minus 1. That's what we are seeing here. Now distribute the summation for the first term and for the second term inside the bracket. So if you substitute in the first term, you'll get 8 outside. Summation n tends to 1 to infinity a n minus 1 x power n. Sorry, it's distributed. It's correct. Am I correct? This is correct. X power n plus summation n tends to 1 to infinity x to the power n minus 1 xn. So here the xn is distributed inside that. So that is correct. So 8 summation n tends to 1 to infinity a n minus 1 x power n plus summation n tends to 1 to infinity x power n minus 1 x power n. Yes, very interesting. Am I correct? Now 8x summation n tends to 1 to infinity a n minus 1. This xn we can write like x power n minus 1 and x. Am I correct? Xn can be written as x power n into x power n minus 1 into x. We can write like that. So that only we are substituting here. That x to the power 1 is bringing before. That x brought before. So what you will get is that 8x, x is coming out, therefore minus 1 summation n tends to 1 to infinity a n minus 1 x power n minus 1 plus the same way. Bring 1x before, then here you need 1x, so x and minus 1 when you bring 1x in front of the summation. So x into summation tends to 1 to infinity x to the power n minus 1 x to the power n minus 1 into x. Now from this to here, from here to here, summation n tends to 0 to infinity a n x power n. So actually this is nothing but when n is equal to 0, when n is equal to 0, what will get? A naught x power 0 you will get. Am I correct? 8 inside the bracket. First term what will get? N naught, a naught x power naught plus a1 x power 1, like that. So that exactly equal to this expansion. You expand this and you will see that it is exactly equal to this expansion, or expand this and that would be exactly equal to this expansion. You expand it and see that here n is equal to 0 to infinity 10 to the power n x power n multiplied by x. That would summation definitely would be equal to summation n tends to 1 to infinity x 10 to the power n minus 1 and x to the power n minus 1. Okay, right, the same way this summation exactly equal to this summation. Very nice. Okay, now what is g of x? Now look at that. G of x minus 1, g of x minus 1 equals 8x into what is g of x? Go back and see. G of x is equal to summation n tends to 0 to infinity a n x power n. G of x equals summation n tends to 0 to infinity a n x power n. Okay, so substitute that value here. So gx minus 1 is equal to 8 into this x will come, I think so. 8 into x, x is missing here. You add that x here, okay? So 8x into, this is what? G of x plus x into, what is this? What is this? Already we know that x into, if you expand this, you will get 1 plus 10x power 1 plus 10x power 2 plus 10x power 3. What is that? That is equal to 1x divided by 1 minus 10x. 1 minus 10x. Okay, that's what. This expansion of this is nothing but 1 divided by 1 minus 10x. That's what we studied previously. Am I correct? Now how this comes? Gx minus 1, This you bring this side. Gx minus 1 minus 8x gx equals x divided by 1 minus 10x. Yes, it is true. Am I correct? Because this term we are bringing this side and this side, this only would be there. That is x divided by 1 minus 10x. 10x. Now rearrange the left hand side. G of x minus 8x gx minus 1 equals x divided by 1 minus 10x. X divided by 1 minus 10x. Now which is common here? G of x is common. Bring the g of x outside and remaining items here or remaining terms here is 1. You bring this gx outside, remaining terms minus 8x. 1 minus 8x. This is common. That equals 1 plus x divided by 1 minus 10x. 1 minus 10x. Yes. Now cross multiply 1 minus 10x plus x divided by 1 minus 10x. Now simplify this. Minus 10x plus x minus 9x. Therefore 1 minus 9x divided by 1 minus 10x into bring this 1 minus 8x this side. So g of x, actually here g of x equals 1 minus 9x divided by 1 minus 10x. Bringing this down this side, you will get 1 minus 8x. So g of x equals 1 minus 9x divided by 1 minus 10x into 1 minus 8x. Now what's this? Do you see anything here? This right hand side now partially for partial fraction done on this particular right hand side. Partial fraction chapter. Okay. So 1 minus 9x divided by 1 minus 8x into 1 minus 10x. 1 minus 8x into 1 minus 10x. 1 minus 9x divided by 1 minus 8x into 1 minus 10x. Just right hand side we are partially fractorizing. Partial fraction. So this we can write as a by 1 minus 8x plus b by 1 minus 10x. Now take the numerator after doing this cross multiplication. You will get a into cross multiply 1 minus 10x plus b into cross multiply, you will get 1 minus 8x. Now the denominators are equal, therefore the numerator must be equal. Denominators are equal. We are multiplying this. Am I correct? So the numerator must be equal. That is 1 minus 9x equals a into 1 minus 10x plus b into 1 minus 8x. From this we have to find out what is the value of a and what is the value of b, like that. Okay. So let us find the value of x here. So 1 minus 9x is this side. Suppose x equals 1 by 10. X equals 1 by 10. This will get x is equal to 1 by 10. You will get 1 minus 9x divided by 1 minus 1 0. You will get this, and then here 1 by 10. This will go off, and you will get here b into 1 minus x is 1 by 10. This side 1 minus 9 into 1 by 10, and simplify this, get cross multiply, you get 10 minus 9 by 10. Here b cross multiply 10 minus 8 divided by 10. Here 10 minus 9 1 by 10 equals here 2 by 10 b. Therefore b equals 1 by 2. B value is 1 by 2. Now if you take x is equal to 1 by 8, here x is equal to 1 by 10 we have taken. As a result we got the value of b. If you take x equals 1 by 8, then you get the value of a is 1 by 2. 1 by 2, that's the value of a. So substitute the value of a and b in equation number 1. Where is that equation number 1? Actually it is here. This is equation number 1. This is equation number 1, not this one, but this is equation number 1. Okay, so if you substitute that in this equation, a by 1 by 8x plus b by 1 by 10x, what you are getting here is 1 by 2 common, bring it out, 1 by 1 minus 8x plus 1 by 1 minus 10x. Okay, so outside 1 by 2 is common, but here already we know the power series that this is in the denominator. The 1 by 1 minus 8x will have the expansion as 1 plus 8x power 1 plus 8x power 2 plus 8x power 3 plus dot dot dot. Similarly, this is equal to 1 plus 10x power 1 plus 10x square plus 10x cube plus dot dot dot. So if you simplify that, the summation form would be like this. This is also summation form for this. Okay, we know from expansion of this short form, this is summation form for this particular expression. So summations are common, x power n is a common, we can bring the summation outside. Summation n tends to 0 to infinity, this 1 by 2, this xn is common, bring it out. What are the remaining terms here? Is 8 power n plus 10 power n. 8 power n plus 10 power n, because xn is common, bring outside, this is common, bring outside, it's 1 by 2 you are bringing inside. So this is generating function, the g of x. If g of x is like this, what is this? This is a of n or an. Am I correct? If g of x is equal to an x power n, summation an x power n, then this is equal to an. So an equals 1 by 2 into x power n plus 10 to the power n. Okay, so this is the solution set for the given non-homogeneous recurrence relations. Non-homogeneous recurrence relations. This is the solution set. That means what? This is a sequence. For n is equal to 0, 1, 2, 3. You'll get a naught, a1, a2, a3. What are they? Those are the sequence. And that particular sequence will satisfy this non-homogeneous linear recurrence equations. Okay, so thus we can solve the given problem. You play this particular video again and again, then you'll get some idea. Otherwise we cannot get some idea about solving this type of problems. Okay, alright, these two problems, simple problem of a linear homogeneous type, I am giving you as an assignment. Write this and do as we did before. Okay, not this problem, this is a non-homogeneous problem. Before that, this problem is a homogeneous type of problem, linear homogeneous. So solve this problem very easy. I'm giving you this as assignment. Come on, note that, write that in your note, and you find the answer for this. Okay, find the answer. Have you noticed that? Write that. Come on, write this. Solve AK equals 5ak minus 1. 5ak minus 1. 5 minus k. Where a naught equals 5, a naught equals 5, a naught That's why k equals 1, 2, 3. Second problem, solve. AK, 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 equals 7k minus 1, 7k minus 1, 7k minus 1, 7k minus 1, 7k minus 1. A naught equals 5, A naught equals 5, A naught equals 5, A naught equals 5, A naught equals 5. So find out the solution for these two, and you can discuss with you whether all of you getting the same answer or not. Otherwise you call me, I will help you. Thank you.